In this video, we want to derive the rule for partial integration, also known as integration by parts. In other words, we want to remember this long and perhaps complicated looking rule, and even if we think we already remember it, we want to at least be able to come up with it by ourselves so that we know we are indeed remembering it correctly. And our trick in doing that will be not to think of this as partial integration, also not as integration by parts, but to think of it as the reverse product rule. So I've taken the liberty of writing the product rule out here for us. So let's compare these. We start here in the rule for partial integration with the term involving f of x and g prime of x. And indeed, f of x and g prime of x makes an appearance in the product rule as well. So these correspond to each other. We end the rule for partial integration with a term involving f prime of x, g of x. And indeed, that is also present in the product rule. And the only term left over here is f of x times g of x, and here is fg of x. But by definition, these two things are the same thing. So we see that all of these terms correspond to each other. So we could rearrange this equation here, starting with this term here and then subtracting this one from the other side, and we end up with this here. And in this form, we can easily see the similarities between these two rules. Now, if we take the integral of both sides, those similarities become even stronger. So let's do that. Here I have already written that out in green, what is changed. I've simply taken the integral of both sides. And according to the rules for dealing with integrals, we could also go ahead and just break this up into two integrals, and I've done that in the next step. So nothing complicated has happened. We've just broken this up into two integrals. And at this point, we have almost got the complete rule for partial integration in front of us. The only thing left to do is just to write this out fully and make one last small change. So here we have the integral of the derivative of fg. In other words, fg itself. So we can just write that this way, remembering to incorporate these limits of integration, a and b, and then subtract what we had above without changing it in the least. And if we indeed want to have something that looks exactly like we had up here, we can go ahead and make use of this rule here, that fg of x is just equal to f of x g of x, and we could rewrite this like this, f of x g of x, and we have derived the rule for partial integration, also known as integration by parts, but best remembered as the reverse product rule.